Hello everyone. In this video we will continue to examine the concept of electric fields and in particular the idea of potential difference. So when we started this little section, we got to this idea of electric potential difference by asking ourselves, in a basic circuit or in any kind of situation, what do we want to say about energy in a circuit? Energy is generated in the battery, it's delivered to charges, and then that charge delivers or transforms that energy in the lamp to produce light and heat. And we wanted to ask ourselves, okay, how much electric potential energy is delivered to those charges? How do we figure out how much? And the answer is, well, it depends on the source. Okay, so how much potential energy depends on the source, and then it depends on the amount of charge. And if you wait for longer, more energy is delivered to the charge. And this idea, the source, is rated with an electric potential difference. This is our new concept, which is the electric potential energy per unit charge delivered to the charges at the source. That's why sources, sometimes known as voltage sources, although we want to avoid that word voltage, are given in volts, where a volt is a joule per coulomb. So a 10 volt potential difference is giving 10 joules per coulomb to the charges in the circuit. That's the essential idea. That definition is codified in this formula here, where delta V is equal to W per Q, where W is sort of work. Remember, potential energy or work are two sides of the same coin, really. And so if you want to calculate the amount of energy given to charge in moving across a potential difference, then you just take that potential difference and multiply by the amount of charge. That is what is shown in this formula here. So, this is an important disambiguation slide for potential difference. Potential difference is one of the most confusing terminological things in circuits. The ultimate idea will turn out to be pretty straightforward to use once you get used to it, I promise. But the terminology is just terrible. So I'm going to go through some of the terminological problems explicitly. Big picture, this is a terrible name. It's better than other alternatives, but it's a terrible name, and we're going to go through some of the tricky things related to potential difference. The first thing to note is that electric potential difference is not electric potential energy. Okay, they're related, but they're not the same. It's the potential energy per unit charge. You're dividing by the charge. So 10 joules per coulomb or 5 joules per coulomb, right? It doesn't tell you anything about how much charge you've got, right? So that's important to recognize, and that's captured in this formula here. It is a difference in a physical quantity called the electric potential, which will be studied in topic 10 by higher level, although not by standard level, okay? So this isn't in the core, and that is a little bit weird. We're dealing with a quantity, it's a difference between two things that we're actually not studying at standard level, okay? But in recognition of that, sort of presaging that, I just want to point out that that's part of why I'm always going to use, or try to always use, delta V when there's a potential difference rather than just using V, because V means potential and delta V means potential difference. So here's a little diagram that shows the difference. You can actually write or calculate what's called the electric potential at any point. So you can say, what is the potential right there at A? And let's say it's 3 volts, because it'll be in the same units. Just like a position is difference from a distance. And actually, I should mention that. That's a really good analogy here. Potential is like your position in some coordinate system. It's like saying you're over here or over here. Let's say you're at 4 meters or you're at 10 meters. Potential difference is a distance between them. Okay? It's the difference between them. So potential difference here between A and B is 7 volts. And as it turns out, the potential difference between any 2 points is way more important than the actual value. Here's another way of saying it. right? We're at some elevation here. You're sitting at some elevation. Let's say it's, I don't know, 120 meters above sea level. That's kind of like your position. But what really matters in thinking about gravitational potential energy is whether you need to climb up 10 flights of stairs or climb down 10 flights of stairs. That is, what is the difference in your elevation between where you are now and where you want to go? It's the height that matters. That is the difference between those two positions, if you're climbing up the stairs or climbing down the stairs, not where exactly you end up. So who cares that you end up, at 140 meters above sea level? What matters is that you're 20 meters above where you started. Same thing here. What matters is the potential difference, not the potential, at least for SL for now. And so the difference between point A and point B is 7 volts, and that's our potential difference. This is the idea that we're all going to use a lot. This is said, or usually the way we'll sort of describe the potential difference of 7 volts is by saying it's the potential difference across A and B. Or sometimes you'll say it's the potential difference between A and B, because what you're representing is the difference between A and B, and not like what the value is right here, what the value is right there. Okay? Now, why is this even more confusing? Well, unfortunately, I think this is a real problem. The IB uses a symbol capital V for the potential difference. It also uses a symbol capital V for the potential. This is a lot like using H to mean both the height above the ground and the difference in heights above the ground. So there is an analogy for this, but in this particular case, I think it makes it way more confusing. Why? Because the unit volt also uses this symbol V, okay? Which means you have a potential difference, right, delta V, equal to 7 volts, written as 7V, okay? This is confusing, and I'm sorry about that. For the IB makes it worse. The IB will use the symbol V to mean the potential difference, and then it'll give a number like 10 with the unit volts. So you'll get equations like this in the IB. V equals 10V, which should bother everybody. But that's just the way life is. Okay, so the difference in the potential is 10 volts, means that the difference in the two potentials at any particular point would be 10 volts. Even worse, and I mentioned this before, much of the world, right, the rest of the world uses the word voltage to mean all 3 things: the unit, the quantity potential, and the quantity potential difference. I'm going to do my absolute best never to use this word. I'll probably mess up at some point just because it's ingrained in me the same way it's probably already ingrained in you, even though you haven't studied this yet. So I'm going to try to stick to using the phrase potential difference here. When I mean potential difference, to use the word potential when I mean potential, and to use the word volts when I mean the unit. All right. Well, I'll save this for the next video.